Okay, hello Internet. Welcome to another science experiment with myself, Jeremy Musso, one of the literacy coordinators at the NWT Literacy Council. So today we're going to be making something called elephant toothpaste. I'm not sure if any of you have heard of this in the past. It's a cool little experiment. It works along the same sort of lines, like it creates a chemical reaction, so it's chemistry based, again, similar to the experiment we did last time. But this time we're going to be using some different compounds. So, don't mind my dog. First we'll need some everyday dish soap. I have President's Choice brand. You can use any kind, just as long as it's sort of a thicker dish soap, such as this. You will need some dry yeast. I'm using just some bread making yeast like this. You will need hydrogen peroxide. So any brand that you choose or that you have in your house, I'm using the 3% solution, which I think is pretty standard for hydrogen peroxide. And then I'm using just a plastic water bottle. If you have a different kind of bottle, that's totally fine. This tends to work a little bit better with bottles that tend to narrow at the top. You do not have to have that, so if you're using more of a glass or something along those lines, that's completely fine as well. It doesn't matter as long as you have something to hold all of our chemical compounds as we add them in. I'm using a funnel again. It tends to help with adding the ingredients to each other. I understand that this might not be a small enough funnel, might not be something we had or you have. So like last time, you can make one out of a cue card, just by sort of taking it lengthwise and folding it around so that the bottom becomes narrow enough that you can, so that the bottom becomes narrow enough that you can use it in the same way you would use an everyday funnel. It helps if you tape those edges together, and that will hold and create your funnel. So first thing we are going to do is activate our dry yeast, or instant yeast. So what I'm going to do is add about 2 tablespoons. So with this one last week, the measurements weren't, I sort of said kind of just eyeball it and see what happens. With this one, it works a little bit better if we are more precise, as we are focusing more so on a specific sort of chemical reaction, and it helps a lot when you have the proper number of each component within, the proper components within each one. So if you want to play around with it, do it on a larger scale. I recommend just like doubling everything or et cetera, to get the desired result. You can play around with it a little bit, of course. We're being scientists in all of these experiments, so I recommend toying around with it and seeing what you can figure out to make the best reaction, but trying to keep the ratios of your components somewhat in the same range. If you end up with way too much yeast or way less hydrogen peroxide, you probably are going to have some issues with the result overall. One thing I would like to mention, I have a baking sheet here that I'm going to be doing this on top of. If you want to put down some, like a plastic tablecloth or any kind of something you don't mind getting messy, if you don't mind it all over the counter, that's fine as well, but it will be a little bit messier than last time. It won't be as contained. Okay, so to activate our yeast, I'm going to use about 2 tablespoons of this dry yeast and about half a cup of pretty warm water. So yeast is actually a living organism, and we can't expect it to thrive. Right now you can think of it in its dry state as hibernating. So yeast is a fungi. It's in the same family as like mushrooms, and what it does as an organism is it breaks down sugars and creates other things. So you use it. It's used in fermentation processes. Or used in, like, baking bread is one of the most common ones. This is actually called bread making yeast. So what happens with that is the yeast will eat sugars and break them down and release gas, generally carbon dioxide or oxygen, depending on what it is eating. In this case, it is going to break down our hydrogen peroxide, which is made up of hydrogen and oxygen. So this takes about 5 minutes, so that's why we're gonna do this first. So pretty warm water, about half a cup's worth. Just get mine from the tap here. Doesn't have to be super hot. If it's not warm enough, that it doesn't activate the yeast as quickly. And when I'm saying activate the yeast, all that means is it's you can think of it as the yeast right now is hibernating, and by activating it, we're waking it up so that the yeast will do its job and break down our components. So there's 2 tablespoons of that into the water. Give that a good stir around so that all the yeast gets some water on it. And yeah, this will take about 5 minutes, and then it might, if it's a little thick still, you can add a little bit more water to help speed up the process. Okay. I'm gonna add just a slight bit more for me. And then I'm gonna set that off to the side. Okay, now, put that away, we don't need that anymore. Next, we're going to use our hydrogen peroxide. Now this is, it's a chemical, so we need to be a little bit careful with hydrogen peroxide. We don't want to spill it. So if you like, it's always good to have assistance and help to make sure that you don't spill these sort of things, as they are, especially the hydrogen, that's the only one that is, it's not dangerous, especially at these low concentrations of 3%. Like some people, like the idea is you can put it around cuts and stuff to help with the healing. But you still don't want to spill it and get it everywhere, especially if you don't have to. So I'm going to use about half a cup of hydrogen peroxide. And as I said, mine's 3%. If yours is higher, that's totally fine. I don't know if it does come in any higher, but just if yours is, that will not be an issue for you. About half a cup of that. Now using my funnel, 1105. I'm going to add the hydrogen peroxide to the bottle. Again, if you have someone to help you hold the bottle to stabilize or hold your funnel, that's definitely not a bad thing. I'm actually going to do mine over the sink because I'm just alone. Okay. So now that we have that, our next ingredient, our next compound is going to be our dish soap. About a quarter cup. This one is the one that can be a little bit eyeballed. It doesn't have to be super precise. But yeah, I'm going to use about a quarter cup of that. And pour that into there as well. So you will notice that when the dish soap is added to your hydrogen peroxide, you will see some bubbling, not a ton necessarily, but you will see that there is a little bit of a reaction already taking place. So I'd give that a swirl to mix them up. And again, that's about maybe a quarter of the bottle, and you can see the bubbles and foam forming on top of there already. Go back to our yeast. Getting there, still looks like it might need another moment. So again, as we're acting as scientists, I would like you to think about what is going to happen here. What you think will happen, and if you have any idea as to why it's going to happen, that's also good to think about. Always thinking about what we're doing, why we're doing it, and why we think our hypothesis is going to come true. Okay, getting pretty close here. So I don't know if I mentioned, but yeast acts as a catalyst. So essentially what it does in this reaction is it's going to speed up our reaction. So I'll explain that a little bit more after we actually do our experiment. Oh, I actually don't have any food coloring. I did mention that that was a good item to have. If you do have any food coloring, you can go ahead and add it to your bottle solution right now. I unfortunately don't have any. It's not imperative to the reaction, it just makes it a little more colorful. So if you have food coloring, go ahead and add it to your bottle now. So my yeast is looking, let's see if I can show you, is kinda like it's soupy, but it's It's not super thick, but there's no big clumps or anything in there, okay? So I will let you, as per usual, go first so I don't wreck any of the results for you. I'll give you a moment. So go ahead and add your activated yeast to your soap and hydrogen peroxide. As soon as you add that, the reaction is going to take place. So remove your funnel and maybe take a step back and just wait to see what happens. I'll give that just a moment. I think there's 5 of you that might be following along, so I'll give you just a second to go ahead and do that, and then I will follow up shortly. Okay, hopefully you've all had a chance to do that. I am going to go ahead now. I'll move it nice and close for you. And I will add my dry yeast, or activated now, yeast to my hydrogen peroxide solution. And there it goes. Hence the nice baking sheet underneath to catch all of this. Don't know how well you can see what's, there we go, that's a little better. The light was a little off there. So that will continue. So that is our reaction. So as I had said, hydrogen peroxide is made up of hydrogen, evidently by the name, and oxygen. Now, without getting too specific into the chemistry reaction that just took place, the way you would write that is H2O2. So for any of you that are kind of familiar with that kind of terminology or that kind of writing, you might recognize that water that we drink every day, our tap water, is written as H2O. So the only difference really in the structure between hydrogen peroxide and regular water is that there's another oxygen molecule attached to that water molecule, essentially. So now that might sound like a minor difference, but it really does make a whole world of difference in what this actually is. You can drink a lot of water every day and never have any issue. I would never recommend drinking any of this, as it would make you very sick. So it seems minor, but it is a big change. And that's one thing that's kind of the beautiful part of chemistry, is that little changes and little tweaks to our chemical compounds create massive changes. So I'll just show you here how much extra foam I had spill out. So almost a whole baking sheet filled with it. So what just occurred is the hydrogen peroxide, H2O2, broke down when we added the active yeast. The yeast, as I had mentioned, is a catalyst, which means it speeds up our reaction. So I pointed out when we added the dish soap to the hydrogen peroxide, you could already see some bubbling, a little bit of foam. So hydrogen peroxide just left out in the open like that will break down on its own, and you will be left with just water and oxygen. What our catalyst did so yeast is a eukaryotic or multicellular living organism. The same as we are, just a little more simplistic than we are. Sorry. So yeast will then attack, in a sense, the molecules in the hydrogen peroxide. And when that happens, it breaks it down, and we are left with H2O, water. So if you were to look in your bottle underneath all that foam, you're going to have water now, which we did not add any water, but now we have water in the bottle. And what escaped, what became our foam, is oxygen. What the dish soap acts as a trap. It catches all the oxygen that is now being released by our reaction, and then naturally, as more and more of that foam comes up, foams right out of the bottle, and as you can see, there's quite a lot of it. So all you're left with now, assuming that all of the hydrogen peroxide broke down, which may take a little bit longer yet, is you will have water and you will have oxygen trapped in the foam, and then as that oxygen escapes there, you will have dish soap and water. That's all that's going to be left from our reaction. So naturally, if you go on YouTube and look up elephant toothpaste, you can see some much more dramatic versions of it, and where the foam will actually like explode and shoot out of the bottle. Now that's done with a much higher concentration of hydrogen peroxide, about 30%, so 10 times more concentrated, which means there's more hydrogen peroxide in the solution than there is in the one that we buy for our homes. There's also a different catalyst used in a lot of those ones. So instead of using activated yeast, which does do the job, they can use different chemical compounds which accomplish the same thing at a much faster rate. So the quicker this reaction happens, the higher your foam would shoot out of the bottle because it's being created that much faster. So in this one, it's relatively slow because our concentrations aren't too high. But that, again, that's where you can kind of play around with it. Maybe add a little bit more yeast, add a little bit more hydrogen peroxide, see how that goes. Again, try to keep the ratios somewhat similar. So I think I have covered everything that I can in this experiment. I hope you enjoyed this. There's lots of these sort of household experiments that you can do, and I hope to keep doing them with you over the next couple of weeks. Yeah, so that's about it for me. Everyone have a great day. Stay happy and healthy out there. I know it's getting really nice, so try and go for some walks. Enjoy some of that nice warm weather if you can. And I will see you all on, I'll have to double check, I believe it is next Monday or Tuesday I will be doing another experiment with you. And I will post details of what that will be and what you will need to follow along at a later time. So thank you very much. Have a great day, and I'll see you next week.